Hi, so we are back on the Lights Out app to talk about WebSockets. First, why WebSockets? Why do we care? Well, here we have the game and it's working, but there is a problem. Notice the requests that the browser is making. It's making many requests, and we can go to the Network tab and we can see a big list of requests that is fetching the game state. It's doing the get game request over and over and over, almost every 200 milliseconds, to see if the board has changed. And in most cases, it hasn't. I'm talking to you, I'm not playing the game, the board is the same. So the browser is doing the request over and over and getting the same answer every time. That is bad because, well, first, it's a waste. Second, the server has to respond to many requests, more than it should. And even then, if the network is slow, I can click on something and I can see the lag. So if I'm playing this on a slow network, I might see the lag. So the solution to this problem comes in two parts, and we are only going to talk about WebSockets. The second part of the solution we won't talk about, that is for you to search on your own. So let me briefly just mention what is this second part. So the second part is commonly called latency compensation. What that means is that instead of clicking on the button, making the move request, and then 200 milliseconds later doing the get game request to update the board, what we do is we extend the functionality of this button on the client side. So in JavaScript, we extend the functionality of this button. So the move function will not only make the request, but it will also change the lights on the board. To do that, we have to re-implement the game logic in JavaScript so that we can do this change on the board. And then 200 milliseconds later, we get the new game from the server, and it will probably be already updated with the new move. So that will be all fine. It will be in sync. If it's not in sync, if something happened, like suppose there are multiple people playing the game, playing the same game, then the changes on the server will be different from the ones on the client side. And in that case, the server has priority. So the server is the ultimate source of truth. The browser is just doing latency compensation. It's just compensating for the latency of going to the server and then back again. So this, from the player's perspective, it feels smooth. It feels like the request is instantaneous. Under the hood, JavaScript is doing the move request and the get games request and everything like it usually does. It's just a visual trick that some apps do. And we are not doing that. I guess you can imagine how that would go. I mean, just in the move function, we would extend it to do the changes on the lights. That's more or less all there is to it. Let's focus on the other part. The other part that is to prevent the browser from doing the requests over and over and over to get the ultimate source of truth from the server, right? So this requires changes both to the client and to the server, so both to JavaScript and to Java. And we are going to see the JavaScript part on this video and the Java part on the next one. So I always like to start with the client because I think that's a better way to drive the development. So that's what I'm going to do. I'm going to start with the client. So let's go to the JavaScript for the Lights Out game. So this is it. And the function to blame here is this guy, right? This is the guy that is called every 200 milliseconds to poll and see what changes occurred. So instead of doing this, we are going to replace this with some other code. We are going to change this code. And now, in particular, what I want to do is to create this WebSocket. And a WebSocket is different from a regular request. So when you do a regular request using fetch, for instance, you're doing a request and you have to provide every piece of data necessary, like the game identifier, or maybe even the whole body with a coordinate for a move. So you have to provide all the data. And then the server gets all this data in the request, does the processing that is necessary, and responds, the HTTP response. And after that, the connection is closed. So the server responds, the connection is closed, and the next time you want to interact with the server, you have to provide all the data again. So you have to provide the game identifier every time. like you see in many places in this application. A WebSocket is different from that because it opens a connection between the client and the server, and the connection just stays alive. So the connection is just there. At any point, the client can send more requests, and at any point, and this is the critical bit, at any point the server might just send more data. So when the game changes on the server is just going to send more data to the browser. And it doesn't require the browser to do a request because the connection is just open, it's just right there. And you don't have to keep providing the game identifier every time. The connection is just open, it's just there. It's almost as if you have this socket, hence the name. I mean, a network socket. So let's do this in instead of pooling. So let's create another function that I'm going to call new game state WebSocket. The purpose of this function is to create this WebSocket I'm talking about. So the first thing is I'm going to create, like I have the game identifier here that is global for the whole application, it's a global variable. I'm going to have this other thing that I'm going to call the game state WebSocket. And like game identifier, it starts null. I'm going to use the let keyword to define this guy because I'm going to change it. And it starts null. So the first thing I need to do here is to assign to this guy. So I'm going to say game state WebSocket equals new WebSocket. And this WebSocket class, it comes with the browser. You don't have to import it from anywhere. It's right there. And then when you are creating this object, you have to pass the address, the address you want to connect to. And when specifying addresses in other places like here, you just say what is the request part of the URL. You don't have to say the server name or the protocol or anything. That's just implied. So you don't have to say, for instance here, HTTP. You don't have to say anything like that. You can, but you don't have to. But in the case of WebSocket, the defaults don't work. So the defaults are whatever the browser already has as the protocol. So you don't see it here, but there is an HTTP protocol here specified. And that's why fetch works by default. But in the case of a WebSocket, the protocol is not necessarily called HTTP, it's called WS for WebSockets. And similar to how there is HTTPS, there is also WSS. That is the secure version. And we don't have that enabled here, so we're going to say just WS. And then here we have to be explicit about where we want to request or where we want to open this WebSocket to. So in our case, we want to open the WebSocket to our own server, on our own machine. And we could just say localhost 7000, but then when we deploy this to Heroku, it won't work. It would try to connect to a local server. So instead of doing that, you're going to use some variables with the location thing. The location thing already comes with the browser. It's like WebSocket, it's like document, and many other things. Location it exists in the browser, and you can just use it, and it's an object, and it has this property called hostname. And if you're running localhost, hostname is localhost. And if you're running on Heroku, then hostname would be ooslightsoutherokoweb.com or something like that. Similarly for the port. So we can say location port. Okay. And now we have to say the URI part. So this part here, for instance. Yeah, that's exactly what I need in this case. So I'm going to connect to this exact same address, but the way we are connecting is different. So there are many methods when you're doing HTTP, like get, post, put, and so on. You can think of a WebSocket as another one of those. That's why these addresses are the same, but they don't clash. So we are never going to change the existing API. This endpoint will remain existing for people that need it. Like let's say another client that we have isn't updated yet, besides this web app, we could have a mobile app that plays the same game and they are not updated yet, so they don't support WebSockets. So we are not changing the existing endpoint. We are just creating another one, and it has this different mode, the WebSockets mode, so it doesn't conflict. So now we have this WebSocket. Now, what can we do with it? Well, we can, for instance, add an events listener every time we get a message from the server. I said before that the server can initiate a message. If there is something new in the server can tell the browser, oh, here's some new data for you. And this event listener will get that data and it will handle it. So I, for instance, can say event, and that's the argument to a function. So this event listener here is has a handler that takes the event. The event will contain the data. And the data is really just what the server sent in the message. And that will be, it will be equivalent. The server will send, we'll do that in the next video, the server will send data that is equivalent to this data that it sends for this get game request, okay? So it's exactly the same. And what we want to do is similar. So we want to render the JSON and get the board and then render, right? So here, when we had this request, we could use the .json method. It was asynchronous and all that. In our case, we don't need to do this because we get the data right away. So this WebSocket behaves differently. You don't need the .json method. Instead, this is just literally a string. You can just work with it. So we can call this other way of parsing JSON, JSON parse. JSON is something that already comes with the browser, like WebSockets and so forth. And it has this method called parse. And it takes a string and returns a JSON object. So we can just do that. And then with that, we want to get the board because the JSON that is returned from the server is an object that contains the board field. So we get that. And finally, we call render. And this line here, this event handler, really is similar to the intent of this function here, right? It does the same thing. In fact, it's replacing that line. And now, okay, so we have this new game state WebSocket function. Where do we call it? Well, for one thing, I want to get rid of polling. So I'm just going to get rid of the whole polling thing. When I do that, I don't actually need sleep any longer. So I'm getting rid of that as well. Now, where do we call this new game state WebSocket function? Well, I propose that you call it when you create a new game. Because every time you create a new game, you want to update this connection to a new one that goes to this new URL. You want to open a new connection altogether. So I propose that we say new game WebSocket right here. Okay, and when we do that, think about it. When you do that over and over, you create a new game, and then you go and click on new game, on the new game button. You are going to create a new connection, and a new connection, and a new connection. Well, what happens to the old one? That's why we are keeping this as a global variable, because we can always ask if the game state WebSocket is not null. Right? In the first game, the first time you run new game, this is null. The second time and the third time and so on. This is not null. And what do we want to do with it? Well, we want to close the previous one. It no longer serves any purpose, so we can just call close on that. And there you have it. That's all you need to do to create a WebSocket from the client side. Unfortunately, this doesn't work yet because we have not implemented the server side of this. So in the next video, we'll do just that and test everything in the browser. I see you there.